Organic reactions so far. Previously, we went through two basic types of reactions that occur with organic molecules: combustion and substitution. The complete combustion of hydrocarbons, or of compounds containing only C, H, and O, produces carbon dioxide and water. Substitution reactions remove an H and replace it with something else. In one type of substitution reaction, halogenation, a halogen atom is substituted in place of an H. The third type of reaction that we're going to meet for organic molecules is the addition reaction. And in an addition reaction, a multiple bond is broken and two things are inserted. Whenever a multiple bond is broken, the sigma bond remains intact. You might remember that a double bond consists of one sigma and one pi. When that double bond is broken in an addition reaction, it's the pi bond that breaks. The sigma remains intact. A triple bond, you might remember, is one sigma and two pi bonds, and so one by one the pi bonds are broken as you are adding something in. Let's try a few examples. Here you can see we have ethene, and we're going to add some bromine to it. Here's why when you break that double bond you will have to add two things. You can see the picture here. I got two people holding hands. That's like the double bond. If they let go of one of those hands but keep the other one intact, hopefully you see then that each person now has a free hand to bond with something new. That's why whenever we have an addition reaction, two atoms are inserted. So both of these bromine atoms in Br2 are going to be inserted into this molecule. Similarly, if we add HBr, the pi bond here will break, opening up two spaces for each of these atoms. So the hydrogen will attach to one of the carbons, the bromine will attach to the other. The same thing happens here. This time we're adding water, and that means that the OH will bond with one of the carbons and the H will bond with the other. And here you can see we have a triple bond between two carbons. When we add two chlorines, one of these pi bonds in the triple bond will break, opening up two spaces so that the chlorine atoms can bond. If we were to add chlorine, potentially we could break the second pi bond here and we could make this a compound that has only single bonds, and we would add two more chlorines, and so on. So every time you break a pi bond and have an addition reaction, you add two things in. A specific addition reaction is hydrogenation, in which hydrogen is added across a multiple carbon-carbon bond. Usually hydrogenation requires a catalyst in the form of a finely divided metal that helps rupture that multiple bond so that we can insert the hydrogen atoms. Here's a hydrogenation reaction. We're going to break the pi bond that's between these two carbons. The sigma bond is going to remain intact, and we're going to go from ethene to ethane. Another addition reaction is polymerization. You can see that if we break the pi bonds in these double bonds, what we're going to end up with is potentially a very long chain of these carbons. I haven't drawn them all in there. If you start with lots of ethylene and polymerize them, you get polyethylene, many ethylenes.